Hi everybody, my name is Fraser Cain. I am the publisher of Universe Today, and this is your virtual star party for July 29th, 2012. We are going to be having a very probably short virtual star party tonight. Maybe, I'm not really sure. We've actually only got 2 active telescopes tonight. So we've got Gary Gonella, who is in Los Angeles, and you can see he's got this beautiful view of the Eagle Nebula. And actually, in his house with him today is Scott Lewis, who's here for color commentary. So they thought they'd have a get together before actually doing the star party. So it's very rare that we actually get a chance to meet everybody. So this is really cool that you guys got a chance to meet.
Gary's
Someday
right
I'll meet.
Right
He's right there. You can just see him. Yeah. Just a few. There you go. One. This is just a precursor for the big test that's going to be happening next week. So, and then we've also got Teale Britstra, who is down under in Australia. Hey, Teale.
Hey, everyone.
And what's great is we've actually got some sunspots this week. So normally, last week actually, we had no sunspots. It was a very bland sun. I think people didn't even believe you that it was the sun. But this week you've actually got, I'm seeing probably, I see 5 or 6 right now, 7. Yeah, so it's quite a few sunspots. So maybe we'll move around a bit on the sun and take a look. And then for color commentary this week, we've got Mark Behrendt, who's in Chicago, and unfortunately it's clouded out tonight, although he had some beautiful shots of the video of the moon last night. So he's going to be showcasing some of these videos of the moon that he took last night. And so you can see it's really too bad because we really only get a nice view of the moon once a month or so, to sort of happen in this time. And Mark, it's like this night, and unfortunately Mark was clouded out. And Corey was clouded out, and yeah. So anyway, so we've got Scott Lewis, who's actually at Gary's house this week, which is pretty cool. And we've got Stuart Forman, who is on the road, but he thought he would just join for color commentary as well. So let's get started. So first, so why don't we just start with the sun before we move back? I think it's going to be Gary's show tonight, but why don't we start and just have a quick look at the sun? So Teale, can you zoom in on some of those sunspots that you're seeing?
Yeah, sure. I'll zoom in on this large group here.
Yeah, so there's like 3 there. I see like 3 or 4. And you can really see the difference, right? You can see that the darker umbra and then that lighter penumbra around the sunspot there. And actually, the sunspots often go in pairs, right? So you can actually see, when you see them from the side, the magnetic field lines are actually twisting between those 2 sunspot groups. And these are actually positions on the surface of the sun where the twisted magnetic fields, like the sun has these really complicated magnetic fields all across the surface of the sun. And what happens is these field lines, over time, the sun is rotating at different speeds, and these field lines get all twisted up. And these field lines can actually poke out of the surface of the sun, and so that's where you see these sunspots. And then sometimes they'll just, they'll shift around, recombine, and the sunspots will change. And other times we get these flares where so much energy will get packed up into these magnetic field lines, and then they'll just snap and spray this material at us, and X-rays and such. So it's really neat to be able to see these sunspots.
What kind of solar filter are you using?
I've just got a plain white light filter on from Thousand Oaks Optical at the moment, so just one that blocks like 99.999% of visible light.
How are you getting the yellow color?
When you buy filters for your telescope, you can either buy ones that give you a white color, or you can get ones that give you a yellow shade. And I just found that well, first of all, the white ones weren't available when I tried to buy it, so I just grabbed the one that's got the yellow tint to it.
I way prefer the yellow look.
Yeah, mine is white. Fraser doesn't like it.
I have you fake it, have you color it.
Yes, you
orange. Use the orange filter on it.
Well, because sometimes it'll come up pink or purple. So
pink or purple or green. We got a green sun. So, so just to give people a little bit more housekeeping, a couple of things. We're going to be able to take requests tonight, and hopefully, all the pressure is going to be on Gary, so he'll be shifting that telescope as fast as he can to keep up with all of the requests. But there's a bunch of ways that you can communicate with us. So you can reach us. If you're watching this on YouTube, you can comment on YouTube. If you're watching this on the event notification on Google+, you can comment there. If you're actually watching this in the stream, on the Google Hangout on the stream, the one that ends in, I'm not really sure what it ends in. Anyway, on the Google+, we can handle your comments there. Or if you're watching this embedded on CosmoQuest or some other location, you can always use the hashtag StarParty, and we'll see it there. So, oh, Pamela's going to try and join us. I'm just going to see if I can get her to join us in the Hangout.
Yes, come hang with us, Pamela.
Come hang with us, Pamela. All right, let's see if she's going to be able to join us. Great. So let's take a look. Oh, so Gary, do you want to just show off that telescope again? I love that. There we go.
Yeah, I'm slewing over to Coddington Nebula.
Coddington Nebula. Did we do this last week?
No, it was on the list a while back, but we haven't been there. So right now, this is I've got the Eagle.
Yeah. So before we lose the Eagle, people should just take a nice quick look at this. So this is the Eagle Nebula. Now, it's actually looking pretty washed out right now, which is, you got a good reason for that, Gary?
Yeah, I'm real close to the moon.
Yeah.
So I'm getting that the light from the moon in the upper part. But if we zoom in on the nebula itself, you can start seeing a little better. And
there's those classic pillars of creation.
Pillars of creation, which just awesome.
Well, you know what's really funny about this is, like, now in the summer we've been getting requests like, when can we see the Great Nebula in Orion? Can we see all of this winter stuff, right? Yeah. And the hilarious thing about this is, while we were in the winter, everyone was asking to see the Pillars of Creation and the Eagle Nebula and all that. And so now it's like week after week we're showing the Eagle Nebula, and then come Christmas it's going to be Orion. So people will have to get used to the. You can't please
Whatever
everyone.
You can show, they don't want. So.
So now we're going to break my rule because we have so few telescopes tonight. Like literally, it was just person after person, clouded out, traveling, technical problems. So really just down to an absolute skeleton crew today. So Mark normally would have captured the moon live. He's going to show us some video that he took last night, which, like I said, breaks my rules. As I said,
yeah. Sorry for showing reruns, but it's only about 24 hours old, so it's not that bad.
Yeah, exactly. Yeah, an encore episode of The Moon.
There you go. So this is just a full full screenshot of the moon. Looks like the Hangout clips a little bit of the top and bottom of it, but this is 5x on the bottom half of it, and there's just a ton of craters on the bottom half. I don't know why that's got more craters than the rest of it, but it looks awesome. Then what else did I have? This section of it looks pretty cool.
That's really cool, and it's such a great time to be looking at the moon because you get these nice long shadows on the craters. It's almost even a little too late. We're starting to lose some of the. It's another week earlier. It looks really nice, but here you can still see all of those really long shadows over on the Terminator there, and you can really see the craters. So
and this is a post-process one. This is 100
neat.
images stacked that I did last night. So this is stacked, sharpened, so you can get a lot more details around the ridge lines and everything.
Did you use Registax for that?
Yes, I did.
Oh,
I'm not very good with it. I probably now that I'm looking at it again, it looks like I probably overdid it a little bit, so I'm going to have to dial it back.
That looks wonderful.
Yeah. So it's neat to show the difference. Can you actually go back and show the video?
Yep.
And then?
So here's the video. And then of this video, this lower third add-on doesn't like it when you turn it off and on again. Hang on a second. So there's back to the processed.
And just to be clear, what we mean by stacked is what he's doing is he's taking a video which has taking about 2,000 or 3,000 frames, and then using software to take the top. You can set what you want, like 10 or 15 or 20% of the frames, and you throw out the bad ones, and then the software will take those each individual frame and align them so each frame is on top of each other frame, and then stack them up, and then it'll use software to do point-to-point sharpening, and that's how he's getting the nice sharp picture.
Yeah, if you look really close, you can see the wavy lines of the heat coming up off the atmosphere, and being able to stack it kind of takes the good parts of one image and combines them with the good parts of another image. So you hopefully allegedly get a full image that's good. There's another crater that I have. That one's a little bit out of focus. It's so hard to focus on the moon because parts of it, are in focus and parts of it are out of focus. So it's really hard to get everything in focus on it. So there's my reruns. I'll show the processed one I did of the entire thing.
Of the entire moon.
Yeah. So there's the entire moon processed. You can definitely see a lot more of the detail in it. If I'll flip back to the video here.
Nicole's here.
Yay!
Hi, Nicole.
She probably can't hear us yet. So you can really see the difference. It's sort of almost like it goes a little darker, and just everything becomes just a lot crisper. Nope. Goodbye, Nicole. And I was just saying that a couple of weeks ago, I guess last month, yeah, Mark had the moon up like this for the whole time, and we had an airplane go right past the moon perfectly. And I just wish he had the video.
Yeah, I wish I was recording because I blinked and I missed it, but everybody else saw it.
If you go back into the YouTube video, you can actually see the moment when but the problem was it wasn't big on the screen. It was one of the small ones on the film strip down below. Yeah, so you didn't have it even big, so we lost it.
It wasn't embiggened?
It wasn't embiggened, yeah. There we go, there's Nicole. Hi, Nicole.
Hi.
So a bunch of questions have piled up here, so let me just kind of get through them. So Ron Bask wants to know if we can see the coat hanger asterism. Can you think you can pull that up, Gary?
Yeah, let me take a look here.
And before you do, though, let's take a quick look at what you've got on the screen right now, although it looks pretty blurry.
Yeah, give me another 5 seconds and I'll have a 2-minute exposure, but with the moon up, I don't think I'm going to get a lot out of this tonight. It's also not in a real good position. This is the Coddington. Yeah, that's a little bit better.
Yeah.
Which is not actually not a nebula. I did look it up today, and it is a stretched out galaxy.
Oh.
Cool.
So you can see it right here, where it's stretching across. But with the moon up, I've got a lot of light in the sky tonight, and that's a very, very faint object.
And then if you could put M57, of course, on your list. So let's try the coat hanger. It'd be great to see that.
Okay.
Actually, so Ron wants to know if your field of view is too narrow, but actually your field of view is really wide. I think you'll be able to see it.
Yeah, I should.
Yeah. Scott Reed wants to know if it's ever possible to see the Apollo landing sites. It's possible to see the Apollo landing sites like this, like there they are. So if you can see the moon there, there are the Apollo landing sites, but you can't actually see them in any level of detail. The only way, even the Hubble Space Telescope can't show the Apollo landing sites, but NASA's Lunar Reconnaissance Orbiter, which has been in orbit around the moon now for the last, year or so, has taken beautiful pictures of the Apollo landing sites. You can see the footsteps of the astronauts on the moon, and the most recent one is they've been able to image and see the shadows of the flags on the moon, and that the flags are all still there, which is really cool. So, yeah, so go to
Yes,
Cosmo.
go to CosmoQuest.
You can map the moon and get a chance to see these Apollo landing sites while you are mapping the craters on the moon.
Yeah.
Yeah,
Yeah,
occasionally you can hit one that has footprints in it.
Correct me if I'm wrong, but if you look at on my moon image here, the middle left big black spot there, the Apollo 11 landing was somewhere in that right above that triangle that points into that middle upper left black spot.
Is that the Sea of Tranquility?
I believe so, because I saw somebody else had an image the other day where they blew it up, and they're like, yeah, see here, this one pixel here is where Apollo 11 landed.
Take that, moon hoaxers.
Alan Huff wants to know if there are any comets visible right now. None that will look very good. Like, there might be some really little faint comets, but nothing that's going to look really good in our view right now. There's another one, too. Somebody wanted to know what Gary's telescope is. Gary, you have a C14, right?
Correct. Yeah, the
Yeah.
Celestron 14.
Yeah.
It's pretty in real life. Just
Right there.
Here's a picture of his telescope. And normally you can watch it moving around as he slews from object to object. Is that it?
This is the coat hanger, but I've never been able to see a coat hanger in there.
I see it.
I see it. The coat hanger is top to bottom, right? So go do that line. That's the bottom of the coat hanger, and then the hook of the coat hanger is that little sort of circle on the left there. Yeah.
Okay.
Yep.
So you do need a bit of a wider field of view. Can you somehow make your field of view wider with this one, or are you?
No.
You're wide. You're as wide as possible. Okay.
Yeah. Yeah.
That's one of the few things I could see from Staten Island growing up under light polluted skies. I was very proud of myself.
Binoculars?
With
Or
binoculars.
just with your eyeballs? Yeah.
Binoculars.
Okay.
One of the few things I could see with a telescope or binoculars that wasn't completely blotted out by streetlights.
Let's see.
What's so funny is Gary and I are over here side by side looking at this monitor.
Yeah.
Does the coat hanger have a number, like a designation?
I think it's an asterism, so no.
Yeah, I found it listed under asterism, so.
Yeah, I'm just wondering what if I can. Is it? Oh, it's Brocchi's cluster.
Well, better give it back to him then.
No, it doesn't like that. Colander 399. Oh, there we go. Okay.
Colander? Like the thing you put the pasta in? Yes.
Yes.
Tinfoil hat.
Like that.
Hold on. I'll show sort of what you're looking at here. Man, screen sharing is so awful in Linux.
Someone was mentioning before that they weren't sure why there were more craters on the southern part of the moon. I think I heard that earlier. And generally that's indicative of an older surface, right? It hasn't been, covered over by lava at some point in the past. So It's got all the original craters in it.
So this is what you will see. So I'll zoom out a bit. So there's the summer triangle there, right? There's Altar and Vega, right? And then kind of almost in the center of the summer triangle, there is the coat hanger.
Malberia.
Yeah. That totally, so and then with Gary's view, you've zoomed in now, Gary, haven't you?
No.
Or have you moved on?
I moved on to M57.
Oh, okay, all right.
Whoa!
We've moved on. Well, so there you go. So we got the coat hanger.
Hi, Pamela.
Hello. Sorry, had been suffering from error 500, whatever error 500 is.
Wait, in Gmail?
No, it's trying to get a person to join a Hangout on air. You get this error 500. Trying to give a person a link to a Hangout. It's been causing us some problems.
Because I've been having that problem with Gmail for like 3 days now.
Oh no. I love the error of doom.
So there's M57. Seems a little. How long's that exposure, Gary?
That's a 60-second, but it's a 2x2 bin. So I'm getting a little more resolution than the 4x4.
It's such a tiny object, and you have such a wonderfully large field of view that this seems like a strange... It looks awesome, but the equipment isn't quite the right equipment.
Yeah.
That's cool.
Yeah.
Terra Nebula.
There's my whole field of view.
So I need to get a few things, a little bit of station identification happening here quickly. We've been joined by Dr. Pamela Gay, my co-host on Astronomy Cast. So hello, Pamela.
Hello.
And if those of you missed it, we were joined by Dr. Nicole Gugliucci, who is the noisy astronomer and works with us on CosmoQuest.
Hello.
Now, this is going to be, we're not going to be doing a virtual star party next week, and that's because during this slot, we're going to be doing our massive, complicated coverage of the landing of the Mars Science Laboratory, aka Curiosity. And we're going to be going all out on this one. We're going to have... let's see. So I'm going to be hosting it. We're going to have some combination of Pamela Gay and Phil Plate helping me to host and provide the color commentary. Scott is going to be live on location at starting at Planet Fest for part of the day, and then he's going to go to JPL to join in on the landing. We're going to be bringing in live video feed from NASA into the Hangout, and we will be silly. So I think that's really what's going to happen. And we will try. And we've got a whole bunch of other special guests coming along. We're going to be interviewing people. We're going to be So that's going to be next week.
I think the key is we will be silly and scientific. So if, like me, you're kind of tired of the NASA TV droning voice and a monotone that is government mandated, but highly interesting while government mandated. We're not going to be that. We're going to have just as rich a content, just as much truth in our silliness. So we're just going to have more tone of voice.
And a bald astronomer in the field. Who knows what will happen.
And it's actually, so we're going to go for 4 hours. So we're going to start at 8 p.m. Pacific Standard Time. And then we're going to go right through the landing itself and to midnight Pacific time. But
we're actually Sunday night or Monday night? Sorry.
Sunday night.
Sunday night. Okay.
Monday morning for you.
Monday morning for you. Yeah.
Well, I'll be. I don't know where I'm going to be. I think
you're going to be in Arizona, and we need to find you someplace.
Yeah. Pamela, where am I going to be? Where are you sending me now? Yes, you're
I'm sending you to Tucson.
No, and I will have internet, so I can join.
So what you're going to want to do is you're going to, while you're watching this right now, if you're interested, you can go and sign up for this event. So you're going to want to go through the events and do a search in there for the Curiosity event, and sign up to that event, and that way you'll be able to know and get a notification of when we start. And we're actually going to be doing this in conjunction with the good folks at the SETI Institute. So they're going to be doing a party before us, starting at 5 p.m. They're at NASA Ames, and they're going to go for 3 hours. They're going to have a bunch of special guests. So we're going to join with them, and then we're going to go and do the last 4 hours from Planet Fest in JPL. And we've never done this before. We're going to be making it all up as we go along. But we hope to keep you entertained. So I think that's the plan. Just as professional as anybody else.
Sure.
No. More
No, because that would be boring.
That would be boring. I know. So you're going to see a lot of fumbling with technology, a lot of like I said, that's why I call it silliness. Whoa, Gary, what is this?
That's M51, the Whirlpool.
Nice.
I heart.
So this is a bright blue galaxy with a kind of beige-looking friend. And if you take a deep enough exposure, you can actually see there's an arc between the two of them. And it's thought that the reason that the bigger galaxy has such a perfect pinwheely structure is because of the gravitational interactions with the spud that it's gravitationally attached to it.
You just call it a spud?
Yes, I did.
I love it.
She calls many things, but usually she reserves that for asteroids.
Okay. An elliptical galaxy is a fairly big spud. So
Yes. It would feed a lot of people.
I heard M51. That was one of my early years of grad school. We had to do this imaging project with an infrared telescope, and that's what we imaged and made a tricolor image of in J, K, and fake H, I think. I don't remember. It was a while ago.
That would be very cool.
Yes, it is cool.
What is J?
Those are the names of color bands in the near infrared.
So JK is not just kidding.
Just kidding. No. Yeah, well, no, that was the made-up third color, so.
So I'll give you some context here for a second here. So you can see here in my stellarium, you can see the Ursa Major here, aka the Big Dipper, which of course you follow the two end stars, and that takes you to Polaris, which is the North Star. And there's the Little Dipper. We can all do this. If you can't do this, then get outside and learn to do this. But right under the
unless
end
you're in
of
the
the
Southern
Big
Hemisphere,
Dipper,
then it's okay.
Yeah, listen to something. Teale, you've never seen the Big Dipper, have you?
Yeah, no, it's too far north for us. I think we see just the tip of it.
Oh.
Wow, Teale. Get with the program.
Come on, find your way to the North Star. Right, and so you can see the end of the handle there, and right below the end of the handle, that's where M51 is located. And we will zoom in like that.
And it's remarkably faint. It's something that I've never succeeded in finding in binoculars, no matter how dark the site was, but I have kind of cruddy eyes. So if you can't find it with binoculars, blame your eyes.
Okay, I'll do that. Because I couldn't. I needed a 30-inch telescope to find it. That's what it took.
You need a 30-inch telescope.
I have found it with a 30-inch telescope as well. So.
Yes. Nothing smaller.
Yeah. No, you can. I mean, that's something that you can definitely get. I mean, especially if you have a camera hooked up to it, you can pick it up in smaller telescopes with dark skies.
I found it with my 8-inch Dodsonian in really dark skies.
Okay.
But I knew. But I needed a good star chart and know where to look.
Yeah, you can find it with a 6-inch in a dark site, 8-inch in a normal site. You should be able to find it in a 4-inch, but it depends on your eyeballs.
Is that a longer exposure, Gary?
Yes.
Oh, it's nice. Look at that.
And it's binned at 2 by 2, so we don't have quite the square stars we had before. Let me bring it a little bit here. There we go. So
double cluster in
stars.
Perseus. I don't think Perseus is up for you right now, Gary. Somebody just wanted to see the double cluster.
No, it's not.
Okay.
No.
Well, that's one thing I can find.
Yes.
In a small telescope. One of the few things.
That's
I would
one of my
mock you if you
favorites.
couldn't.
Yeah, the double cluster is just right above the horizon for Gary right now. So if we kept going for a couple of hours, then it would probably get up a little higher, as would Andromeda. But right now, it's right on the horizon.
Yeah, we'll see it in the fall.
Yeah.
Yeah, we'll see it like plenty.
Yay.
M101. Well, you're right at M51. So how about going over to M101? Asks Brian Simpson.
No problem.
No problem. It's all the pressure's on Gary tonight. He's our main telescope. And,
But there's this beautiful moon just hanging out here.
Well, you missed that part. We're watching an encore presentation of the moon.
Sorry,
Okay.
Pamela, I'm cheating tonight. I had clear skies last night, but clouds moved in, so I'm just showing reruns from my footage from last night.
That's okay.
It's
Delayed photons.
It's like 24 hours old, so Gary's light is like 20 million years old, so 24 hours.
Showing the rerun.
Physics just owned you.
Dozier Shaw asked, how do you align an older SET to Polaris in order for it to track objects? Does anybody have an answer to that?
So an SCT is a Schmidt-Cassegrain telescope. It's a telescope just like Gary's, except instead of having the light collected by a camera that's at the front of the telescope, you put a mirror at the front, bounce the light out the back of the telescope. That's the Cassegrain part of the Schmidt-Cassegrain. The trick is you need to be patient. That sounds really lame, but you need to take your tripod, very carefully align the part that has the fork mount, goes up and down, very carefully align that straight towards north, and then fuss and fuss and fuss until you get the axis of the fork pointed directly at the North Star. There will be a certain amount of cursing involved. It's one of the reasons that people build permanent mounts for their telescope. I've found that the simple problem of trying to hold the telescope, fuss with the wrench to get your fork mount wedge at the correct height for the wedge, it just leads to pain. Just leads to patience. All you can do is commit an entire night of your life to this instrument. Get it lined up and hope you never have to move it again.
Cement pillars are good for that.
Yes.
I line mine up every time because I can't leave my telescope outside. I've got it's a Mac cast, which is almost the same thing. I just point the front leg of my tripod, kind of in a northerly direction, and because there's a tree blocking my view of Polaris. So I'm like, I think it's pretty much about this way. So I'll line up there. I know I'm at about 42 degrees, so I'll set my base at 42 degrees, and I'll hope for the best.
And unless you're doing astrophotography or imaging, which unfortunately I've always been doing imaging, if you're not doing imaging, then having it not perfect is fine. So just spend 15 minutes instead of 5 hours.
So there's M101.
Right, that's a 1 minute, 60-second exposure. I'm doing a 2 minute right now. Binned at 4x4, so we should see a little bit more of it.
So Shaunen852 on YouTube said, do you guys have any scopes on the East Coast? We normally do. It's just we're all clouded out tonight. But if you want to join us sometime, by all means, we're always looking for more astronomers. So if anyone wants to participate, if you can get a view from your telescope into a computer screen, then we can help you do the rest and bring your actual view right here into the Hangout. So we're always happy to have more people join us. This is any size telescope, large, small, remotely operated, hand-guided. We're happy to have anyone join us and participate because we really like to show just the different views. And so, Teale, with the view of the sun right now, he's got an 8-inch celestron. Mark's got an actually even smaller one. And Gary's got a 14-inch, so it's sort of a nice range of telescopes. So we're happy to have anyone join us. Stuart, when he normally has a telescope, his is actually a 150-millimeter refractor, so it's a completely different telescope. So it's a great, just a great range of telescopes. So yeah, by all means, anyone who wants, please join us. Got a question about the planets. There are no planets up to. Well, Pluto's up. But that's it. And actually, we had Pluto.
Planet.
We had Pluto 2 weeks ago, which was really cool.
I'm gonna get in trouble.
It's a classic planet.
It's a dwarf planet.
And a classic
really
planet.
Count.
So
it's a cartoon dog.
Continuation of this conversation from the office.
Everyone vote. Pluto, planet, not a planet.
Planet classic.
Classic planet.
You don't see Gary's complaining. That was a planet too.
I'm willing to call it Planet Classic as well.
Okay.
It totally messes with the acronym I learned.
I know.
My very excellent mother just served us 9 pieces. Without Pluto, it doesn't work.
Yeah.
Yeah, then it becomes your mother served nothing.
Yeah. Or just nothing. I'm getting an echo from... Oh, Stuart, sorry. Yes, Saturn and Mars are up. Mars is very low to the horizon now, so unfortunately we can't really get it. Saturn is up and it's beautiful right now. Unfortunately, none of the telescopes that we have going can really get a good view of it. So Mark would be good for getting Saturn, but he's clouded out. Stuart would be good for Saturn, but he is on the road. Gary's view is actually really good for the deep sky stuff. Wide field, it's not planetary. It's not good for planetary stuff. So unfortunately, we don't have any planets tonight. Jupiter and Venus are in the morning right now, and but unfortunately, none of our Europeans are available. So, like I said, we're going. My excellent mother just served us nachos. That's a good one. So we're on sort of a skeleton crew tonight. We got more color commentary than we do have telescopes. But 2 weeks ago we had 8 telescopes. So you never know what we get.
Okay, that's a 2-minute of M101.
Ooh.
That is beautiful. That's fantastic. Yeah.
So one of my favorite words in astronomy is flocculent. This is a flocculent spiral, so it's not as well defined as the last one that we saw.
Can
the
you say
arms
that,
are
mixed
kind of.
company?
So what does flocculent mean?
I've only heard it in terms of these type of spirals, so I think
it's like
messy.
feathered patterns.
Feathered, thank you. Yes, kind of feathery arms, not well defined, like
It has
like
much
an
flocculation.
flocculent.
I don't even know what that means, but I'm going to laugh at it.
So I just put a link to next week's event into both the Google Plus Hangout conversation as well as the old event, the event for this Star Party. So if you're watching this in either one of those, you can click the link and go to that event and sign up, and then it'll go in your calendar and you'll be reminded. It should be a lot of fun, so you don't want to miss it. So we've got a bunch more requests now. Someone wants to see the owl cluster.
I think that's a nebula. It's a little tiny, cute nebula.
Yeah, ANGC 457. I'm trying to remember what we saw with that. We see it with your scope, Gary, right?
Yeah, it's pretty small, but you can see the 2 eyes.
Yeah. It's under Cassiopeia. It's pretty low right now.
Yeah, it's a ways near the mountains for me.
Oh, you know what? So someone is actually asking for the owl cluster, not the owl nebula. So the owl, yeah. So the owl cluster is just in Cassiopeia, just below the W of Cassiopeia. So it's really low on the horizon for Gary.
And did you see 457?
Yeah.
I like that I can give him designations, and he's right here.
So NM Wheelie asks, for non-professional photographer, any recommendations on a camera or star lunar photographs? Is there any way to take a picture of the moon in focus, or do you need a telescope?
300 millimeter lens on a Canon T, whatever number is the newest number, I series, works beautifully.
What does one of those cost? Like $1,500?
No. You can get the camera. I want to say the camera plus the lens. It's kind of pricey for that lens. It's about $500 altogether. You can get it with the next smaller lens, but then the moon looks kind of sad and tiny.
You can also get a refurbished Canon T1. I got one from, I think, BH Photo for like $200 or something like that. And so you can get them refurbished for relatively cheap if you get an older model.
So the real key is to be able to see the details. You want to get the largest number millimeters on the lens that you can. So 300 millimeter as the top number on the telephoto lens. The cheaper lenses that go that zoomed in are, I want to say, about $150 to $190 depending on what sales you hit. So you can get them for a reasonable price. It's just the camera body. You have to also pay for the camera body. But I would use that a lot.
I would go with what Mark has got. I would say if someone wants to get nice pictures of the moon, he's got the perfect setup, and it's not that expensive. I mean, you can get, if you wait and get one used, you can get a telescope like what Mark has. I don't know, can you bring your telescope into the field of view at some point, Mark?
Yeah, sure. I'll grab it.
I would say if you get it on sale, you can probably get it for about $300 or so, and you can connect the camera to it. In fact, I got all my T adapters, but unfortunately I can't connect them to my telescope. But so maybe Mark can show how he's got it set up. Then people can see what he's doing. Is that it?
This is the owl cluster.
Oh, okay, yeah. So somebody wanted to see the owl cluster.
Discovered by William Herschel in 1787. It's around 8,000 light years away from the sun.
Nice. What's your field of view, Gary?
Degree by a degree and a half.
Right. And so with the moon being about a half a degree, you can imagine you could fit,
in my
4 by 6 moons?
Yeah.
No, 3 by 2. 2 by 3 moons.
Is about right there.
Yeah, that would be the moon in Gary's field of view. Yeah, I've got a bunch of people asking a bunch of questions about astronomy, and I think Brian Simpson is doing a great job of suggesting that people go and check out Astronomy Cast. So if you have really any question about space and astronomy, Pamela has answered it already on Astronomy Cast. We're up to episode 270. You name it, we have talked about it. Black holes, dark matter, dark energy, parallel universes, the end of the universe, every single mission to Mars, astronauts, programs, masers, lasers, time travel, astrology, and what's wrong with it. Everything.
It's really well indexed, actually. So when people ask me questions, I can go to it and find whatever episode I'm looking for really quickly. So it's really nice.
Okay, so great. So why don't you explain then, Mark, what you've got your setup here?
Okay, so here I actually hooked up my Canon straight to my computer here, so this is me moving around so I can actually give you a nice in-depth details here. So this is a Meade ETX90. Brand new. It's about $500. I'll show you down the front of it here. So it's just you can see the mirrors in it. It's the matte cast design, which is just a variation on the Schmidt cast or the SCT that somebody was asking about earlier. Basically, it comes with the the tracking mounts, and it comes with the tripod and everything. So yeah, it's pretty simple. There's a hand control panel with a little go-to computer on it, so you can actually, it helps you align it and tells you where things are in the sky. What other things do people want to see on it?
Well, can you show up where you connect up your camera. Unfortunately, you're using your camera as a camera, but where do you normally connect your camera?
So right in the back here, this unscrews here, and this will actually be kind of interesting to see.
I'll grab my T-adapter so people can see what it looks like it connected to a camera.
I've actually got my T-adapter right here too. So there's this T-adapter right here. This screws onto the back here, and then the lens just, this is like an ISS docking thing right here. So the camera just goes right back on there, and there's a little mirror that flips down to send the image back out into the lens. Body of the camera, and then it flips back up to project out the eyepiece on top.
And so you can look through the eyepiece, make sure you have it all nicely lined up, and then you can switch to getting your view on the camera. Yeah, it's a great setup. I think if someone wants to get started, that's a really nice, relatively inexpensive way to get started. I mean, like I said, watch Craigslist or Astromart. You should be able to get one of these for about $300 used, less maybe.
Cloudy nights, I've seen them for $350 or so.
Yeah, and if you've already got a nice camera, if you've got like a nice DSLR camera, then this is just a big fancy lens for your camera. This is the best way to go. And like you saw the kinds of views that Mark was getting of the moon, they're just gorgeous.
Yeah.
So it's a great way to start. And you can get, I mean, with a telescope this big, the magic really comes with when you're doing the astrophotography, when you're doing these long exposures, then you're getting views of fainter objects. Not so much in light-polluted skies, but in some of the darker skies, you get just really beautiful stuff. So if you just head an hour out of your town, set up, do some long exposures, you get some really nice pictures with a telescope like this.
This telescope and mount is great for seeing the moon or some of the brighter planets, even if you're in a light polluted area. I see Saturn and beautifully through this thing, even in the suburbs of Chicago. If I take it out to a dark sky site, I can see nebulas, I can see some of the brighter galaxies. the tracking on it really isn't accurate enough to do more than, maybe a 20 to 30 second exposure, and that's if you're, if there's no wind and it's, perfectly aligned and, the gods are with you, so to speak.
But I mean, Teale has probably the same kind of mount, don't you? You have a fork mount like this?
Yeah, it's a fork mount. I've just got the slightly larger aperture.
Yeah. So Teale's telescope is a little bit bigger version of this, but as you've been watching, his view of the sun has been rock solid for the whole time.
Well, rock solid in a webcam and rock solid for a 2-minute astrophotography exposure is a completely different story. What seems rock solid, will end up being blurred in a long exposure. That and when you put the extra weight of the camera on the back of this thing, it kind of upsets the balance a little bit.
Yeah, you're not going to be able to do 5-second exposures with. You're not going to be able to do like 5-minute exposures with your setup.
Right. Like I said, I can do 20 to 30 seconds.
Right, and that's where things get more complicated. And so with Gary's view, he's got a really nice tracking system, but in addition, he's got a separate little telescope that's only job is to focus in on one star and guide the whole telescope to make sure that the whole telescope stays perfectly aligned. And so with Gary's view, he can view an object for an hour, right?
I can do a couple of hours of tracking at this point. In talking about the polar alignment, I spent 3 nights just doing the alignment out there, and then again I spent a couple of other nights tweaking it to get it right. And I can do about 2 hours. I can't do much more than that. It starts to drift.
You did what's called a mount model?
The drift.
Yeah. So what ends up happening is if you ever take physics, there's this thing called torque, which means that when your telescope is pointed straight up, it's much easier for it to make small motions without wanting to go thwomp. But when it's over here, that lever arm from all the weight on the front of the telescope is trying to pivot it, or all of the weight on the camera is trying to pivot it. This means that your camera is less skilled, for lack of a better word, less precise in how it tracks the sky when you're tracking further down on the sky versus straight up. So you have to compensate for this with software or by having a tracking camera associated with the system. And this is where things like balance really, really matter. If you've ever had a door that wasn't hung precisely, you know how hard it is to open and close a badly hung door. Telescope's not that different.
Now, you had M13 in there for a second, though, didn't you, Gary?
No.
No? Okay, I thought I saw M13, so...
No, this is part of the North American Nebula that I'm...
Right, okay.
Now. I like this little wispy area in here.
Oh, that's really great. Did the longer exposure just pop in?
Yeah.
Yeah.
The first one was a 10-second. This is a 60-second.
Wow.
Is this Florida upside down, or?
I was just about to ask that. Canada, Mexico.
Yeah,
Is this the Gulf of Mexico?
Okay.
Okay.
Here. I'll move over a little bit and catch a piece of the pelican here too.
So this is a nebula that actually looks very disturbingly like North America and proves that human beings can find patterns anywhere.
Pamela, there's a bit of a conversation going on about teleview eyepieces. Do you have an opinion, or does anybody have an opinion about them? Apparently they're nice.
They're amazing and cost as much as a car. So yes. It's one of those things where if you have a chance to buy raffle tickets, it's worth buying the raffle tickets for this one item because really they're like $500 sometimes for a good one.
A piece.
But yeah, a piece. But they have these fields of view that it's like this little fleck of the sky is filling your entire vision. Most eyepieces, you look through them and there's this little tiny tunnel and you have to do this weird head thing to look down the tunnel. Televiews, it's this beautiful, open, wonderful what's called eye relief, which means your eye can move around and you can still see through the eyepiece okay, and they're just comfortable to view for hours at a time, unlike a super cheap eyepiece.
But if you're going to do some astrophotography, you're often popping that eyepiece out and putting your
if
DSLR
you're doing
in,
photography,
right?
don't get one. If like me, you like to just look through the telescope. My dream telescope is a little TeleVue refractor with TeleVue. They have a zooming eyepiece, which is a great starter eyepiece for the rich. So in my happy dream land, I somehow win that in a sweepstakes.
And what does one of those cost?
A lot.
For my eyepieces, I ended up going with University Optics, and you can actually get, for each millimeter eyepiece, I think they're about $80 or $90, so it's not that bad. And I also got a three-piece set of, I think it's 28, 32, and 40. From Garrett Optical, a really big 70-degree field of view. They're really nice eyepieces, and those were for the three. It was like $200. So you can actually find some decent eyepieces if you look around a bit.
No, there's a lot of really good eyepieces out there. And, honestly, when you're getting started, a nice set of what are called Plössl eyepieces, P-L-O with double dots on top of it, S-S-E-L, Plössl eyepieces. They have good eye relief. They have a fairly large field of view. It's pretty good optics. And they'll last you a long time before you're like, okay, I'm going to spend the car's worth of money on eyepieces.
I want to just look at this sunspot that Teale's got again. It's really nice.
I've got
I'm going to second the Plössl eyepieces, though. Sorry, the Plössl eyepieces are great, and they're actually really inexpensive, and they're really nice.
Yeah, I've got a friend who only does visual observing. He's got thousands of dollars and tens of thousands of dollars worth of telescope equipment, but he's like, if I wanted to see a picture of a nebula, I'd look it up online. I don't need to do imaging. I want to go out and I want to see it with my own eye.
And a good eyepiece like that is really important if you're showing, people who are new to the telescope, because that looking around, especially with kids, to get that image perfect, it's hard to do the first few times.
Yeah. Yeah, so a good Plössl is good enough for school groups, for everyday use. And you're looking at spending tens to over $100 instead of hundreds of dollars. Get yourself, my favorite, just generic grab an eyepiece, you can only grab one, is what's called a 20-millimeter Plössl. It gives you fairly reasonable zoom. You don't have to worry about if the sky is bad, you can't see anything. The smaller the number on the eyepiece, the more magnification. So something like a 4-millimeter or 6-millimeter eyepiece will give you this giant Jupiter. But if your atmosphere is bouncing around a lot, it gives you a giant blurred out Jupiter, and that's no fun. So 20 millimeters, it's hard to go wrong with it.
Yeah, nice sun.
Tried to move over to the Pelican a little bit, and I caught another piece of it.
It's nice to have a star nearby.
For various reasons. Life.
You've switched, Gary?
Yeah, and Scott and I are trying to figure out what I found.
We're whispering back and forth. What is that?
It's funny when people whisper in a hangout.
Hey, if your mic doesn't pick it up.
Well, it's because we're right here next to each other.
Yeah.
Oh,
they're actually physically in space.
I didn't know that. Okay. Okay. It now makes more sense.
They thought they would break all the rules and actually, be in the same room.
Yeah.
Normally we try to keep everyone involved in all online things completely sequestered. Most people didn't realize that Pamela and I hadn't even met for like the first 3 years of doing our podcast together.
It was a year and a half, but yeah.
3 years, 12. It was the first 12 years of doing our
first 12 years.
Yeah.
A little time dilation going on there, huh?
With a little time dilation among friends.
So Tom, it's too late to add the telescope, I think, just because we're probably going to wrap up in the next 10 minutes or so. And then next week we're going to be doing the the Curiosity landing coverage, and then the week after that, we'll be back to doing a Star Party. We're also going to be doing a special edition of the Star Party for DragonCon.
Yes.
But the event that we're going to be doing it is completely sold out. So, so sorry.
And
but if you're going to be at DragonCon,
wait, are you talking about the one that I'm speaking at?
Yeah.
Sold out? When did it get sold out?
Didn't it get sold out?
I don't know.
Well, maybe there's still some tickets. I'm not sure. If you do a search for DragonCon Star Party, you should be able to see it. So it usually gets sold out. It gets sold out months in advance.
It usually gets sold out.
So I just had assumed that it was sold out.
So it's me, and it's Phil Plate, and George Schraub, and Marion Call. I am so excited.
And the virtual Star Party.
And I'm so terribly jealous because I won't be there.
You know what? Shush, you're going to be in Beijing. That's awesome.
So we're gonna kind of after you guys do all your speaking and George plays, we're gonna set up on a big screen there and try to stream in some.
So should I be dressed up too, since I'm hosting it? Since we're all in cocktail attire.
Sure.
Yeah,
yes.
Yeah, that would be great.
With a top hat.
So I had a couple of questions. What time is the the coverage next week of the hangout, the Curiosity hangout? We're gonna start at 8 p.m. Pacific time, so that is 11 p.m. Eastern time, and we're going to go for 4 hours.
We may be popping in and out with SETIs beforehand. Hours start at 8 p.m. Pacific.
Yeah, and lots of guests you've heard of, and people you haven't heard of. So, I mean, who have we got lined up? We've got a bunch of people. Scott Maxwell from the rover driver team is going to be participating. We might get Mike Brown, the guy who killed Pluto. I know some folks from Star Talk might be showing up. We've got, we're going to have perhaps some people from the Planetary Society, almost certainly some people from the Planetary Society. So I think it's going to be a really good time. Actually, I think we're going to be, and this time we'll try and keep it as focused as possible on the actual event as opposed to other guests. So
I think
good.
Figured out what I have here.
It's pretty.
End of Mexico on the North American Nebula.
Cool.
It, just to give you a quick look, this is my field of view indicator.
Okay.
And so this is the North American Nebula. The North America bothers me because it's too big.
Isn't that like you're going to be your life's work is taking one picture of the entire North American Nebula and stitching it together?
Yeah.
There's the Pelican Nebula here, but so I moved down. I was trying to move over to the Pelican, but I moved down to here. So this is the bottom part that would be, you would consider the bottom of Mexico.
I've got a request about seeing the Carina Nebula. We can't see that because it's only visible from the southern hemisphere, right?
And Teale has daylight.
And Teale has daylight.
I actually took a photo of that about 2 weeks ago, if you want me to bring it up as the screen share.
That would be fantastic if you could.
Yeah.
I'd love to see it.
Carina's beautiful.
Yeah, you've even seen it with your own eyeballs, haven't you?
Yeah. Have you, Nicole?
If I did, I didn't know it. I didn't have a telescope when I was in South Africa.
Okay.
Well, except for the radio
telescope. You had a radio telescope.
Except for a radio telescope. I mean.
Except for all those dishes, yeah. But no, I did not put my eye to anything.
Did you not, like, look out and look at the sky?
Oh, my God, I did. All the time.
Yeah.
I was out in the desert. I mean, first of all, there wasn't much else to do except sing Lady Gaga at the top of my lungs inside a trailer.
Of course.
I'm not going to try and understand that.
But, yeah, no, when it was gorgeous. I think I stumbled over rocks several times just staring up at the sky.
And you could see the large and
small Magellanic Clouds, and I freaked out because Orion was upside down, and yeah, it was pretty cool. But I didn't have an optical telescope.
Could you get us M13 at some point, Gary, before we wrap up this week?
I can do that.
That would be wonderful. Thank you. Someone asked for it early on, and then I think we moved to your white whale here.
One of the weirder astronomy experiences I've ever had is my husband and I discovered last Christmas that they have to get the boats from the Mediterranean to Mexico for the cruise lines, and so you can get transatlantic cruises that are fairly inexpensive in the grand scheme of cruises. And so we sailed from the Mediterranean, northern hemisphere, to Rio de Janeiro, southern hemisphere. And as we went, Orion slowly fell over and ended up on his head. So it was this really great day after day watching Orion fall over experience.
That's awesome. Yeah, I got freaked out because the moon was wrong. Like the first day I was there, like the moon, it's not right. There's something wrong with it. And it's like, oh right, southern hemisphere.
Southern hemisphere.
Well, when I was in New Zealand, I saw Orion upside down, and I had a minor panic attack. I said, "This is just not right. The sky is not right."
What does the moon look like on the other side of the planet?
It's just upside down.
Yeah, it was third quarter. And I'm like, why does it look like first quarter in the daytime? I don't understand.
Just take your monitor and just flip it upside down, Mark, and that will tell you.
Gotcha. I can do that in software. I don't have to do that in hardware.
Look at M13.
That's gorgeous.
Yeah, so if anybody doesn't know, this is M13. This is the great cluster, star cluster in Hercules.
So what type of cluster is it?
It is a... it's a globular cluster.
So for those of you who don't get the inside joke, Fraser, who we love... Yes. Canadian. And sometimes it comes out globular.
Globular.
Eh?
Go outside and tell us what the sky looks like, eh?
Take off your hoser.
Are we being racist?
No, we're being culturalist.
Okay, I like it. Culturalist.
My husband's Canadian. I love Canadians, but yes.
They just won't admit they're the 51st state yet.
Wow.
Hey, you want to know something really cool that I can do? Check this out.
Healthcare?
Well, that's what I was thinking.
Have a $2 coin?
So that's it. So it's just me and Mark, and Teale, and Gary here now. So it's okay if all of you talking, they can't hear you.
I can talk because I'm on Gary's microphone.
Oh, that's right.
Owned by physics again.
We'll bring you all back. There we go. Yeah, they've added a new...
Fraser?
Yeah.
Yeah, I'm actually having problems bringing up Karina because Hangout Lower Third isn't cooperating tonight.
Oh.
Try, if it's not hanging, try switching your extension to a different one, like go to comment tracker and then go back to lower third and then see if it'll do it. But it depends on what the image was. If you did it as a really big raw file, it's just going to be too big for lower third to handle.
Yeah.
Yeah, no, I tested it out before we went live to the public and it was working, so I'll just swap to comment tracker and swap back.
Okay.
Yeah, give that a try. Yeah, I find that's just the fastest way to do it is to just ditch it and then come back. So I'm going to show...
love for one another. We're not really being mean. We love each other this much.
We'll show you M13 here. Right, so here's Hercules, and you can see this. It's a great cluster to find because you can see on the chest of Hercules. For me, it's on the right-hand side. Sort of partway in between these two stars on the right of the chest of Hercules, you can see, even with your eyes on really dark sky, you can see this little fuzzy bit. And then when you actually look with binoculars, you can absolutely see it.
It's something that withstands a lot of light pollution. Mm-hmm. So you can see M13 from Austin. You can't quite see it from Boston, but you don't have to go that far out of Boston. We can see it easily here.
Okay, so Teale, you've got it working, so tell us what we're looking at here.
Yep. That one's the Carina Nebula, so it's actually, I think, the keyhole that we can see there. And that was taken 2 weeks ago on the new moon night. So it's basically just my telescope as the lens to the camera and then just a straight 30-second exposure, so no stacking or anything in that image.
Wow.
I'm jealous.
Nice.
No, it's I guess it's in the constellation of Carina. How far away is it from the large and small Magellanic Clouds?
Yeah, it'll be a few degrees. Like at the moment, Tarantula's usually a little bit too low, so that's in the large Magellanic, and usually that's right on the horizon for me, so that's a little bit too low to be taking photos of.
Right.
I'm going to say goodnight, everybody. I got to go.
See you later, Stuart.
So
we'll see you in
2 weeks.
2 weeks.
2 weeks. All right, good night.
Teale,
Thanks.
could you hold up a mirror really high so I can point my telescope at it and get that shot?
So what's kind of
Yeah,
cool
that should be all right.
is this is the counterpart in a lot of ways to Orion Nebula. So when you find something really cool in the Great Orion star forming region, you can then confirm your result by looking to see if you can find the same thing in Carina and vice versa. So nature's given us these two fairly similar in age, giant star-forming regions where we can explore for the proplyds of newly forming stars, where we can look for examples of stars that are just emerging from their cocoons of gas and dust. And they're both these immense, gorgeous systems, and Carina has perhaps the shining jewel. It has Eta Carina, which just might explode any day now, which is kind of cool.
Yeah, I'm fairly
Teale,
sure that's the large...
Sorry, can you post
the
a
large star in
picture?
the image.
Can you post a link to that picture, because actually your resolution of it is blowing out pretty badly. I think people are mentioning this. It does actually, you know what? It does look fairly bad resolution within the Hangout too. I think it's something to do with Teale's internet connection, because normally it should look a little better than this. So. Anyway, if you can post it, maybe post it into the event, because people can post pictures into the event that we're actually having. So at some point, if you want, you can post your link to the event that we're doing right now.
You have to turn on party mode for that.
Did I not turn on party mode?
I don't know. I just know you have to turn on party mode.
We're having a party anyway.
I will turn on party mode. Hold on. Let me edit it and make it sure that people can. I'm pretty sure people can post pictures on it.
Thank you, Google.
Yep, guests can add photos. So you can add photo, and I will put a link to the event in the chat, and then. So Teale, you're thinking that you might be able to see Saturn or Mars in the daytime?
Yeah, the problem for me earlier was it was basically behind my house. So I'm thinking, because we've been going for a little while, I might be able to slew up, and it might be just clearing now.
Well, we're probably going to wrap up in just a couple of minutes, but Mark, this isn't live, is it?
No, this is, somebody was asking about how to take a picture of the moon with a 300 millimeter lens. This is what it looks like through a 300 millimeter lens. I just went through my my old photos, so for those people who wanted to know what the moon looks like through just a camera and not through a telescope, this is a 300 millimeter view of it.
Yeah, and it doesn't compare to the ones through the telescope.
Yeah, I'll switch back to my telescope one, and without the digital zoom, it is.
So are we Gary? We're just going to look at ourselves now.
Yeah. Yeah.
Okay.
We're going to be very meta.
You can look in the
Death Star at you.
Is the internet in there?
Everyone needs to contemplate themselves now and then. This just seems to be overkill.
I can almost see myself in the mirror there, yeah. But what's different with Gary's, which is great, because if you were watching before, you saw Mark's setup. His camera was on the other side, but you can see Gary's is actually that weird box, that octagon right at the end of the telescope there. And so he's sort of minimizing. He's got one less bounce of light going on, and so that's why he has such a wide field of view. He's getting the images right off of the front, as opposed to having it come all the way through the back. So it's
to put
much
it in
wider field of view.
I'm running at about 760 millimeter focal length. So you're talking about the 300 millimeter lens.
Yeah.
I'm like a lens at 700 millimeters, but I've got a real large, so I've got what they call fast. It's f1.8, 1.9.
So there's two different issues that define what you're able to see with a lens, with a telescope. One is the focal length, which controls the magnification when you take into account the focal length of the telescope and the focal length of the eyepiece. The other thing is how large is that opening that's bringing all of the light in. If you have an amazing pair of focal lengths that give you huge amounts of magnification, and they have a very little tiny light gathering area, that's probably called a microscope, and you have to put a large light source underneath whatever you're doing in order to be able to see anything. if you instead have a huge light gathering area, what you're doing is you're taking a lot more light than would naturally hit your eyeball and focusing it down to your eyeball, allowing you to effectively gather more photons that are all coming in parallel to each other from this distant object. So you see fainter things, the larger the mirror. You see smaller things with better resolution, the better the combination of focal length.
You can literally think of light as like, you know, raindrops. And you have a bigger bucket, you're collecting more rain, so you're collecting more light.
So Teale, what do you think? Do you think you're going to be able to do it, or should we wrap it up here?
Yeah, I'm just having a look now. I can't spot it in the finder, so it might be a little bit difficult.
Okay, all right. To see Saturn in the daytime, that would have been pretty rough. So Jupiter looks okay sometimes in the day, right? But I know Saturn's a pretty tough one.
Venus is kind of awesome.
Yeah, he had Venus. He said he had Venus earlier, but just as we got started, it was going behind the building. So yeah, unfortunately. Well, then why don't we wrap it up here? So thanks again. Thanks to everybody. Thanks to our astronomers. Thanks to Teale, and thanks to Gary for giving us the live view of the night sky. Thanks to Mark for showing us an encore presentation of the night sky that he captured last night of the moon. So thanks for that. And thanks to Nicole and Pamela and Scott for bringing us the color commentary, and to Stuart, who has already left us. So once again, my name is Fraser Cain. Next week, just a reminder, there will be no Star Party. We are going to be doing live coverage of the Curiosity landing right here on Google Plus with lots of special guests, live view of the landing, on location out at Pasadena for the Plant Fest, and then over at the Jet Propulsion Laboratory to actually watch the landing. Scott's going to be interviewing people on location. We'll be having other people from all around joining us, so it's going to be a really good time. I pasted a link to next week's event into both the Virtual Star Party and I guess we were watching Gary there. I posted it into both the event and the Google Plus comment thread where this has all been going on, so you can click on there and you can add the event to your calendar, and that way you'll get a reminder of when we start up next week. So just once again, don't forget to join us then. So
Should we call it a Mars party instead of a Mars party?
A Mars landing party, yeah. Is what
Mars
we're gonna
party.
It's a Mars landing party, yeah. You want a Mars party?
I must go buy Mars bars.
Yes.
Yeah.
That's a good idea. I hope are they going to advertise? Only if they pay us.
Yes.
And thanks to everybody watching. Thanks for all the questions. It was really fun, and we will see everybody next week. All right.
Good night.
Good night,
Good
everyone.
night.
Bye all.
Bye.